actually focus efforts and it will be very cost effective. However, I have a couple of comments here. For one thing, this is a question. You propose, instead of using all these huge band of goods, we should instead focus on few band of goods. What made me wonder is that would this small set of goods be representative enough to capture household welfare across countries? And if yes, how best can we go about it? Because the bundle in Uganda may not necessarily be the bundle in other countries. How do you propose that should be addressed? And then immediate to that question is, you discuss a case of Uganda, but what about other countries? Why Uganda? It was not clear to me in the paper why you chose Uganda. I was hoping to get some justification why Uganda would present a realistic sort of test ground for this methodology. One of assumptions that you make on calculation of elasticities is that one condition for calculating elasticities is that these products have to be income elastic. In Africa, income tends to be underreported. Not all the time that you tend to observe the income that you would actually observe, say, in developed countries. And that would tend, I would tend to think that would tend sort of to bias down your estimates. And on top of the fact that, in addition to the fact that not only that income is underreported, but elasticities are not constant. You make a very strong assumption that elasticities are constant. But we know elasticity are stochastic. They do change over time, at least from my experience. So I don't know whether your method will tend to address that, or that will be one of the assumptions imposed for the method. And then you also use R square as a criteria. I'm glad to see the improvement because the previous version had a lot of zeros. So I think it would be interesting to have a cutoff, like at what level of R square then we would say this is the nice bundle you should choose. Because as it is now, you have R square of 0.5, 0.6, 0.2, 0.4, and it's, so if you have a benchmark and say if a bundle passes say 0.5 R square, then that's what we should take. I think that would be also interesting. Your 1% cutoff on the aggregate share is arbitrary. It was not clear to me why 1%. What about the products which are less than 1%? I remember in the paper you talk about them, and then you said that you choose 1%. Why not 2%? Why only 1%? Why not 5%? So I thought I was hoping to get some justification on why 1%. And then the two final comments is, are tomatoes, onions, salt, etc., are they necessarily income elastic? Because you show that based on elasticities, they're more elastic, then that's the reason why one should consider sort of include them in the analysis. But it made me wonder, growing up in Africa, I wonder if I have more income, I'll tend to buy more salt, so to speak. Does it necessarily mean that salt, for example, or tomato or onions, are that necessarily income elastic? I thought maybe that's something you might want to think about and see if it makes sense. And finally, I think it would be interesting for your approach, as unique as it is, to try to compare the results with the standard estimates and see how well it predicts poverty, how well it predicts welfare. And if it predicts well or if it does not, what is the deviation, whether it is meaningful in terms of informing what is going on, and so something like that. Thank you.
Okay, thank you very much. I'm in the awkward position of presiding and also answering. Let me answer some of Anthony's questions or observations first, and then if there's time, take some questions, I guess. So the first thing I'd like, I'll run through some of these pretty quickly. So is this representative across countries? Okay, so not everyone eats a lot of matoke. So this is, I think, a nice feature of this arrangement. The idea is if you can estimate a demand system, for example, for Uganda and then perhaps for Rwanda, let's say, very different kinds of diets in those two countries, but you're able to identify goods that have similar betas. So we're estimating these betas, which are like these income elasticities. If we can identify goods that have the same betas, then in fact we can do a cross-country comparison on the basis of that. Whether it's, I don't know what the equivalent to matoke would be, but it's whatever would have the same level of beta we estimate. So that, I think that opens up some really nice, exciting opportunities to do comparisons across countries, which are usually hard, but in this theoretical framework at least, look like they should work very nicely. You ask why Uganda? Uganda is interesting, but the choice was pretty arbitrary. I think it'd be really interesting and exciting to do some other countries by way of comparison. I've tried to tool up to make that easy to do, but I haven't done it yet. I think there was something misleading about the income elasticity. So the goods you want to choose are the ones that are most income elastic, but we figured that out by a first stage estimation. So we estimate the betas using all the goods, and then it turns out that tomatoes have a high value of beta. And that tells us, the data tells us what's income elastic and what's not. So it tells us that even though salt has a big share for poor households, income elasticity of salt is quite low, in fact. And we wouldn't learn, if we observe salt expenditures, we don't learn a lot about variation in that number about the household welfare, which maybe shouldn't surprise us too much. We'll learn a lot more by looking at changes in household expenditures on restaurant meals or onions or tomatoes or meat, things like this. So we don't need to observe income. The only data that went into the calculations I showed you today were expenditures, individual expenditures, and for the poverty line I had to get one price. That was the price of rice. I used that as a numeraire. That's it. There's no other than that. There's no prices involved in this exercise at all, and especially none of those pesky price indices, which are a problem because they almost always assume. The Lasper's price index, for example, assumes the homothetic utility that I'm complaining about. So I really can't put myself in the position of using that. So a perceptive remark is that elasticities may not be constant. That's right, and here in this estimation, I'm assuming they are. That's testable, but I haven't done it here. I'm not going to, why 1%? Because that's what would fit on a slide. It's, in the estimation, I go all the way down. It's just, I stop, because, and I think, comparing the standard estimates, I actually spent quite a bit of time in working on this paper for this talk, wanting to compare this with the headcount poverty numbers that you get from PovCal from Uganda, which use similar data sources. And so I wanted to have exactly the slide that Anthony wants me to have to show you how poverty changes via my method and via the PovCal reports. And I actually did that, but the results are extremely embarrassing. But the reason they're embarrassing is because I think the PovCal numbers are extremely problematical. In particular, the headcount poverty rate in Uganda in 2005 is reported to be over 50%, and then 4 years later it supposedly drops down to 31% or something like that. And I see no evidence of that kind of drop if I just look at total expenditures in the LSMS data. So I haven't matched. I can do the comparison, but since I don't really understand, I cannot replicate the construction of the PovCal numbers. I'm not prepared to nail anything to the wall yet. Okay, so let me pause there. We're a little short of time, but since I'm presiding, I can take questions. Yes, please.
Both promising and quite intriguing that the data requirements are so much lower. There is one concern I have with it, mostly from a behavioral perspective. A lot relies on the theoretical prediction that the lambdas are the same across the first order conditions for different goods. That might not necessarily be true empirically, especially thinking along behavioral dimensions. There might be issues of salience of goods, and to give just a very simple example, people might pick up on luxury goods too late as they get richer because they have some information cost of finding what nice goods are out there and where to find them and where to buy them. As a consequence of that, the lambdas might not be the same across goods. So the questions are two questions. One, have you checked whether lambda is robust when you estimate the lambda choosing different pairs of goods? And two, are you worried that the method you propose is sensitive to such behavioral issues? Okay,
that's a great question. I have a really, I think, a nice way to deal with that, but one which isn't very informative about behavioral issues. So to think about this issue, what's important is to go back and think about the model the consumer is solving. The lambda in here is, you should think of it as the multiplier on the budget constraint. And in the model I wrote down, that's the only constraint that the consumer faces. Now, in a more realistic description of the consumer's problem, there might be a variety of other constraints. There might be the kind of behavioral issues that you're describing. There might be just things about stocking out, so you run into zero constraints. There might be a whole bunch of other things, a bunch of constraints that we don't recognize in the data when we pose the consumer's problem. Okay, now what happens if I go ahead and assume incorrectly that the budget constraint is the only thing that matters, when really there's the budget constraint and some other stuff that shapes behavior? What will happen in that case is that when I estimate my demand system, provided there's some goods where the budget constraint is the thing that matters, and other goods where the budget constraint and other stuff matters, what's going to happen is that in those second equations, I'm going to get a poor fit when I estimate the demand equations. And so this criteria I suggested of trying to throw out goods where you think there's a measurement error or where you think there's just a poor specification is sort of gives you some latitude to say, oh, for this particular good, my demand model is lousy, so I shouldn't be trying to use this particular good to draw an inference about lambdas. So I can then toss it out. Now, even though, so I still have the same lambda appearing in the first order conditions for every single good that I'm consuming. So there's information in that number for expenditures on goods that have funny behavioral stuff as well as goods that aren't. So I just rely on the ones that seem not to have the funny behavioral stuff to draw the behavioral inference.
So my question is related. So I guess the previous question was about whether you could use different sets of goods to say something about the model that you're using and whether it's the right consumption model. But I was wondering whether you could also use, I mean, the fact that you don't need all the goods to basically do the same test repeatedly and look for consistency across those as a way to find which goods are measured the best. As if you don't have any, let's say you don't have any a priori knowledge about which goods are the expenditure for which are measured best, maybe you could just find the ones that are sort of more consistent with the rest of the data set.
Yeah, so I made some improvements in the paper since the one that Anthony saw and the one I submitted. When I did this exercise a few months ago, there was a serious problem that I faced in the Ugandan data, and that was that most expenditures were zero. So 63% of particular items were reported as zero by different households. And if I threw in those zeros that had the obvious, so the zeros might be there because households really didn't demand the stuff. They might be there because households didn't report the thing. There's a bunch of reasons you could have zeros. But the fact they were there was making my angle curves give me very biased estimates of the betas. Now, it actually turned out not to affect the lambdas too much, but it was still a problem. Okay, so a criteria I developed, though, in that setting was to think about what goods to throw out. And so one of my criteria there was, if only 6 households consumed the good in the survey, I'm going to throw that out because I'm confident that, so infant formula used to fall in that category. I'm going to throw out that good because it's not useful for drawing inferences, really. But a more general, and I mean really slightly ad hoc, but still very useful metric here is just estimate this thing. You're going to get R-squareds for each demand equation. Let me show them to you. So these are the R-squareds I get for the demand setup where I allow for missing goods. So these are R-squareds in the final column. And you can see they vary quite a bit. So tobacco, I don't get a very good fit. That's also true, so that's for whatever reason. I get a pretty good fit, or comparatively good fit for fruits and matoki and so on. But the point is, if I get a really crummy R-squared here, that tells me exactly as I was saying before, that my model is not doing a good job of explaining variation here. So that equation with a low R-squared is a candidate for being tossed to the side. Now that's a rule of thumb more than a nice sharp criterion for exclusion or exclusion that Anthony was asking for. And I think there's some work to be done there. I think the important work to be done there in terms of exclusion and inclusion is going to also need some data on the costs of collecting the data on the expenditure as well. So working with whoever's designing the mini expenditure survey to match up the marginal cost to the marginal benefit of adding an additional good is something else I think is important. And I hesitate to use people's time. There's one more question over here. So let me go ahead and take that, and then perhaps we'll stop.
I'll make it quick. Probably I missed it. Kind of sleepy after lunch. Did I miss something? Well, when you talk about 2 goods, are these 2 goods complementary? Are they substitutes? What are they? So that moving from a huge set of them to narrowing them down, could I end up with a set of just complementary goods or substitutes in that sense? So maybe you could say something around that.
Sure. So whether the relationship between goods, whether they're complements or substitutes, matters a lot in the demand system, of course. And you can sort of think about this too as affecting the amount of information that you get from the expenditures. So if 2 goods are perfect complements, for example, observing expenditures for both of them doesn't tell us anything at all. If they're perfect substitutes, on the other hand, it may tell us more. In the estimation, I'm actually estimating, I'm not putting any restrictions on the cross elasticity. So I get an elasticity of demand for good I with respect to price J, and that matrix is completely unrestricted, except for the fact that I'm assuming that it's constant in this setup. And just as I responded to Anthony earlier, so that's essentially the same as the assumption of constant elasticities, because these thetas are also elasticities. So that's something I'm assuming here. It's also something which is testable, but not something I have tested. So. Okay. All right, so I think we should stop there. Thank you all very much for coming to this session.